Hello, good morning students. Today we are going to start with the rest of the chapter 2nd Physics, class 12th, Electrostatic Potential and Capacitance. In continuation with the previous chapter, this is the second part of the chapter. We are going to start.
Students, today we will study a new topic. Before further proceeding, I want to ask you something. Do you know about this? Sir, it's a resistor. No, Ram, it's not a resistor. Anybody else? Okay, I will tell you. This is a capacitor. It is used to store the electric energy. Now, I am taking two capacitors of 5 microfarad and making combinations from these. The equivalent capacitance value in this case is 2.5 microfarad. The equivalent capacitance value in this case is 10 microfarad. Sir, how the value of equivalent capacitance change by making changes in their combination? Good question, Ajay. Let me tell you. In series combination, the reciprocal of the equivalent capacitance is equal to the sum of the reciprocals of the individual capacitances. However, in parallel combination, the equivalent capacitance is equal to the sum of the individual capacitances. Students, today we will study more about this in chapter Electrostatic Potential and Capacitance. Objectives. At the end of this lesson, you will be able to define dielectrics, understand polarization in dielectrics, explain capacitors and capacitance, describe the parallel plate capacitor, analyze effect of dielectric on capacitance, know about combination of capacitors, calculate energy stored in a capacitor, understand Van de Graaff generator.
Now student, today I am going to take only the first and second topic, that is define dielectrics and understand the polarization of dielectrics. Rest of the topic will continue in the further videos.
Dielectrics. A dielectric is an insulating material like mica, glass, or ceramic. Dielectric materials are of two types, polar and non-polar. Polar dielectric. Polar materials are composed of molecules that have permanent electric dipole moments.
Now, dielectric is an insulating material like the mica, glass or ceramic, and they are of the two types, polar and the non-polar. Polar material composed of the molecule that have a permanent dipole moment. Permanent dipole moment means they doesn't have the negative and the positive charge, concentric circle. They doesn't lie on the same centers. That's why they have a permanent dipole moment. In the absence of electric field, these dipoles are irregularly placed. In a polar dielectric, the molecule dipole are randomly oriented when no electric field is present.
In a polar dielectric, the molecular dipoles are randomly oriented when no electric field is present. When an electric field is present, these dipoles experience a torque and tend to align with the electric field.
Now, once the electric field, whenever we apply the external electric field, these irregularly dipole, they experience a torque, and once they experience a torque, they will align themselves in the direction of electric field.
Non-polar dielectric. Non-polar materials contain molecules that do not have permanent dipole moments.
Not non-polar dielectrics. Non-polar material contain the molecule that do not have permanent dipole moments. Means in these molecules, their negative and the positive charge are concentric. Concentric means they have a same centers. So they are presently they doesn't have a dipole moment.
When a dielectric consisting of non-polar molecules are placed in an external electric field, the positive and negative charges of the molecule experience forces in opposite directions and become displaced relative to each other. The molecules are said to become polarized by the field and are called induced dipoles.
So once the non-polar dielectrics are placed in an external electric fields, they will experience their negative and the positive charge. They will experience the forces in the opposite direction, and they become themselves in a dipole and having a dipole moment. And the molecule are said to become polarized. The ones initially they are non-polarized, but when they experience the external field, they will become polarized and they are called as induced dipole. Now this is the end of the session for today's. Daily I will put the small topics of this chapter so that it will easily understood by you people, and please make the notes in a fair notebook, and whatever assignment I put on the ERP, please make them in a loose sheet. Later on, when you return to the school after this month, your assignment will be checked and 5 marks will be allotted to your written material. Thank you.